Okay, Hess's Law. So we're in Chapter 6, Section 8, and we're introduced to a new, well, I say new, it sort of makes sense. It'll fit nice on your head after you chew it a little bit. Hess's Law. What is Hess's Law? So Hess's Law essentially says, I'm going to repeat this a couple times in this presentation. Hess's Law says, if you have two reactions, let's say A plus B produces C, and we have the change in enthalpy of this reaction is, let's make up a number, -3. And if this is C plus D produces E, then, and this is, let's say, make up another number, -4, Hess's Law says that these can be combined to tell us something about the sum reaction. Can you see that C is produced in this reaction and it's consumed in this reaction? Okay, so if we put these two reactions in the same bucket, then C is going to be nothing. There's not going to be any C there at all, right? So it's going to be A plus B plus D is going to produce what? Look at that. Say it out loud. A plus B plus D, can you see these guys cancel? A plus B plus D is going to produce E. That's right. Okay. So this reaction, let's call this reaction 1, this reaction 2. Reaction 3 is the sum of these other two. All right? This looks just like a system of equations, by the way. It works exactly the same as a system of equations that we learn, systems of equations that we learn in Algebra 2, probably, maybe in 10th grade, maybe 11th. Okay? So what is that then? If this is the sum of these two, then this is going to be the sum of these two. And delta H of this reaction, the change in entropy of this reaction, is going to be -7. All right, so that's essentially what we've got going on here. And I'm going to repeat this a couple different ways, and then we'll do a practice problem or three. So first of all, suppose we've got these different examples given here. A plus 2B. What have I got here? Set here. B. A plus 2B, right? Can you see this is supposing that the enthalpy goes up. By the way, can you see if this is positive or negative? What does that look like? Change in H, that's going to be greater than 0, right? Can you see it's going up? Okay. So if A plus 2B produces C, and C produces 2D, right? Can you see that this is less than 0? That's negative. That's going down. Then we would say that the change in enthalpy of this reaction plus the change in enthalpy of that reaction is equal to the purple. Can you see that? So let's make up some numbers that looks at. What do you think? If we're going to put some numbers on here, what would you call that number? And what would you call this one? Make a guess. You should say it out loud. All right, I'm going to say that this is 3 plus 3, and that this is -5. Right? And can you see that the purple would, a decent estimation of that would be -2, right? So watch this. +3 -5 is equal to -2. And it's exactly how it works. All right? So everything else I'm going to tell you about Hess's Law is a natural consequence of what we see here. But let me tell you what those natural consequences are. First of all, if a chemical equation is multiplied by some factor, then the enthalpy of the reaction, change in enthalpy of the reaction, is also multiplied by the same factor, okay? So let's do an example here in red or black. Let's go back to red. And color red. All right, so A plus 2B produces C on the previous slide. Well, if the change in enthalpy for that reaction is, I'm going to make up a number. What did we say in the previous slide? 3? Let's do that, okay? Then you tell me what is going to be the change in enthalpy for this reaction. 2A, 4B, 2C. What's the change in enthalpy of this reaction? Okay, I hope you said it out loud. It's +6. Good. All right, so if a chemical equation is multiplied by some factor, can you see that what factor I multiplied this whole thing by? 2, right? Then change in enthalpy of the reaction is also multiplied by the same factor. All right, just what like you might expect. All right, let's go back. Let's go back here now. Let's say A plus 2B produces C. Let's just stick with the same system here. Is plus 3. What is the change in entropy of this reaction? Okay, so if the chemical equation is reversed, the change in enthalpy changes sign. Minus 3. Hopefully you said that. Okay, now what I want you to do is I want you to stop the video. And I want you to do, so you see what I did up here? I wrote these out. I want you to write out what this one says. Give an example of what this one says. Make up your own, reactions. Did you pause the video? If you didn't, do it now. Okay, I'm going to assume you paused the video now. Because you're a team player. If a chemical equation can be expressed as the sum of a series of steps, what could that mean? Well, let's go back to what we did in the beginning. A plus 2B, or this is the one we did in the second example, produces, what was it? C, right? And then we said C breaks down to D. I think it was just D. It might have been 2D. What if this one was, we said that was plus 3. This one, I made up those numbers, right? You made up some numbers too. Minus 5. Then what is going to be what's going to be the sum of these two reactions together? All right, watch this. A plus 2B, right? C crosses off. It's a product in one reaction, and a reactant in the other produces what? Say it out loud. D. I know that's annoying for me to say that, okay? I really do believe it's helpful. 2. Good? Boom. All right, let's do an example. All right, so find the delta H of the reaction. Find the change in enthalpy of the reaction as given. And here's what you're given. You're given these 3, okay? So here's what I'm going to do. Number 1, find of my target reaction Number 2, arrange given reactions to accommodate. Okay, so what am I talking about here? Let's go with a different color, red. All right, so look what I got here. I have a propane. Doesn't matter if you know what that is, right? It makes no difference. So if I got a propane here as a product, then I'm going to find a propane here. Do you see it? It's here, okay? So the first thing I'm going to do, I'm going to take reaction, I'm going to call this reaction 1. And I'm going to reverse it because you see it's a product here and it's a reactant here, so I'm going to reverse it. And so it's going to be 3OCO2 plus 4H2O produces propane plus 5O2. I'm leaving the states up to save myself grief. Okay? Now, please pause the video and tell me what is that. Figure it out. Okay, hopefully you pause it, and hopefully you see it's 2043 kilojoules. Do you see it? Okay, so I've gotten my propane. I realize I'm just starting, okay? So I'm going to find the reactants and products of the target reaction, which is here, and I'm going to rearrange these guys so they fit, all right? So it looks like I've got hydrogen here. It's a reactant here, and it's a reactant here. You see that? I'm not going any particular order. So hydrogen's here. I guess that was the most easy one to see because it's so big. All right, so I've got hydrogen here, and it's here. So it looks like it's a reactant here and a reactant here. But it's multiplied by 2. So I have to take this reaction and multiply it by 2. I'm going to have to multiply this one by -1. You see what I did that? Reversed it. Multiply this one by 2. I'm making up my own reactions here. Do you see that? So this is going to be 4H2 plus 2O2 produces 4H2O. So pause the video and write down what this enthalpy is. Okay, I got 967.2. I'm sorry, negative 967.2. Sorry. Negative 967.2. And it's kilojoules, okay? All right, so now let's find this one, carbon. Carbon's here, and carbon's here. So but it looks like it's multiplied by 3, so I'm going to take that one and multiply it by 3. Okay? And so this is going to be 3C plus 3O2 produces 3CO2. Okay? And so what is, please, again, pause the video and tell me what is the change in enthalpy of this reaction. Okay? 3 times 393.5 is 1180.5. 1180.5 kilojoules, and it's negative, right? Because I didn't turn it around. Okay, now let's go through and let's go back to black and see if we got everything we need to make the sum reaction, okay? Okay, so I got my propane here, C3H8. I've taken care of that. My oxygen, there's 5 oxygens here, and look at that, 5 here. And they cross off, you see that? Okay, what about my waters? I got a problem here. Oh, there's 4 waters here. Yeah, look at that. 4 waters here and 4 waters here. Those cross off. Do you see that? Okay, and what about this carbon dioxide? Wow, 3 carbon dioxides here and 3 carbon dioxides here. They cross off. Okay, so look at this. It's important you see this. It's going to get a little bit busy now. You ready for this? These 2 cancel. These 2 cancel. Right? You see what I got? Orange, it's getting busy. And these ones cancel. Okay? So I've taken care of everything that's not marked. H2 is not marked yet. You ready for this? H2, because there's nothing to cancel with H2, right? So it's 4H2. Now that's taken care of. And 3C. And that's taken care of. And wow, look at that. Boom, boom, boom. Love it. Kiss, kiss. All right, so now that I've got that, sure enough, we verified these guys do, in fact, if I do those equations like that, they do, in fact, add together to give me what I'm looking for. So all I've got to do now is just add these guys, right? That's what I'm going to do. I'm going to add them. It's 2043 minus 967.2 minus 1180.5, and that gives me minus 104.7 kilojoules. I love it. I love it. This makes me happy. I think I'm going to put a little symbol in there for those of you who are still awake. All right. All right, congratulations. Do I have another example here?